If you like to build terminal applications, I have something for you called Anathema. It's a 2E library written in Rust, and one of its key features is a custom templating system that not only allows you to separate your layout from the rest of your application, but it also allows you to ship your templates with your application, so your end users have a lot of options when it comes to customization. Here, let me show you. Okay, let me show you a basic example of this. It's sort of a hello world thing where all we do is increment a counter for every frame. It's not terribly exciting, but what is exciting is that we can take this application along with the template and give it to someone else. And if they don't like the way it looks, they can just modify that, right? Whoops. Assuming you know how to write, okay? Templates are hot reloadable, which means that when you change something, it's gonna sort of instantly be reflected in your application as it's running. And the values that we have are reactive. That means that any value that you're using for an element, in this case the text element, is going to update that element, right? To show you this, if we put 3 of these together in a vertical stack, we can see that here, right? And you have quite a lot of sort of customization options, right? That you can do for this thing, right? So this is the template, this is the component, and we've implemented the onTick event here, and all it does is just increment the state, and when it reaches 100, we'll start again, right? Again, it's not terribly exciting, but what it can do, right? The possibilities are they are terribly exciting. Okay, let's go and look at another example. Okay, so in this example, we'll talk about sort of how we can scale an application, right? We'll take the same interesting application and let's look at this template. If you imagine how an application would grow over time, you'd end up adding like status bars and all kinds of fancy things. It's going to be pretty messy if we put everything in one template. So we can break things down into multiple templates, and this is how we do it, right? We have our component counter here for this counter. This is our sort of index template, and if we wanted to add a subcomponent to this, all we have to do is just register that component with a runtime, and we can now use it. So in this case, the component is called inner, and the template is inner. So if we were to open up the inner component, it just says another component, right? And then we can use that here, right? So here we're loading that particular component, right? And we can do that many times with our template component, okay? Now, this component doesn't have any state, but that doesn't mean that we can't pass values to the component. So if I wanted to show the counter inside this one, right? We can say that the counter is the state. And let's do that for this guy as well. But for some reason, I'll show you that we can perform like mathematical operations on the values as well, right? And now we just say attributes dot counter, and there you go, right? This is the one where we are multiplying it by 100, and well, obviously. So you can add like a lot of. You can break down your application into multiple small components and make the whole thing a lot more manageable to work with, right? And even though components doesn't have to have state, we can pass state from outside of the component into the inner components as an attribute, right? Okay, so let's go and look at one more example, and this time we will add a component and have a look at what that's like. Okay, so in this case, we're going to add a new component. But before we do that, we have to add a state. Well, we don't have to, but we're going to add a state to the component. So we'll start with the state. The previous component we had just had a useIce as a state. So it's not a very complex state, and you can just use these primitives for state. You could use a string or a useIce or whatever, right? And in this case, we're going to have a collection and a selected index. And every value that we add to a state needs to be wrapped in this value type, which makes the value reactive. So you can use any of the numerical types, and you can use strings and string slices alike, right? However, for vectors and hash maps, we have a custom map and a list type because they are a little bit more complex on what is actually happening under the hood when you add and remove values and how this should be reflected in the template. We only have a new function here, nothing else. The state just holds data, it doesn't do anything fancy. So we just build up a list from an iterator and we start by setting the selected value to 0. So let's go down and look at what the component looks like. The component has two things that we have to add. There are two associated types, which is the message type and the state. The state is kind of obvious. We just talked about that. I'm not going to get into details of what the message is or how it works, but you can send messages to components either from other components or from outside of the runtime. You can send messages synchronously or asynchronously. So if you're building some complex Tokyo chat application and you want to pass messages to the UI, you can do so very easily by just having an emitter and a component ID, and you can do this asynchronously or synchronously. Right? We have one event for this component, which is an on key. There are many events, and you can see all these events in the guide as well. Right? In this case, we are going to get mutable access to the index, and we're going to call key.getChar. This is a convenience function that we just get a character. You can look at other events as well. You can look at like left and right arrows and so on. But in this case, we're just going to call getChar and see if it's either K or J. If it's K, we're going to decrement the value. If it's J, we're going to increment the value. And we're doing this check so we can wrap the value in case we get past the item length, right? So in essence, all this is a component that will handle the on key event, and it will increment or decrement the index as we go, right? If we now go to add this component to the runtime, we can do so. Here's our old component. We comment that out, right? We can do so here by calling component on the runtime builder, and we are going to pass a template. We named it inner as before, and we pass in an instance of the component and an instance of the state. And that's it. So if we go and look at the inner index here, we can see that we have a border around a vertical stack. Then we have a for loop here. You can have both for loops and if statements inside templates, but it's important to know that AML, or the markup language, is not a programming language. So you can't really have if statements inside attributes, right? So if X is this, then use this color. If it's Y, then use that color. There are ways to express that, but you don't do that with if statements. If statements kind of works like, I'm not going to try to nerd out too much about this, but if statement works like they are elements part of the tree, right? So when something changes, we can go into the tree and just rebuild or change that particular aspect affected by the if statement. So it could be the case that changing the selected index has no impact on the parent element, which means we would stop the layout process there. But all right, let's not get into that one. So what we do is we're going to show every item in a horizontal stack, and if the loop counter, which is a magic value inside a for loop, you have access to the loop counter, which will be whatever iteration we're on. It's a little bit like using enumerate in Rust. So the loop's going to start at 0 and so on and so forth, right? So if the loop is equal to the selected index, then we're going to add an additional element, which is just this chevron here, right? Or lesser than as well. So if we run this now, if I press the J and the K button, you can see how I can move this thing up and down as I see fit, right? And again, everything is hot reloadable. If we want to change this to another value, we can do so, right? And yeah. And I think that's it, right? So there are so much more that I haven't shown here. This was kind of like just me blasting through, trying to give you an idea what you can do with Anathema, or like more that like the whole reactive template system, and I'm kind of excited about that. But there's so much more that you can do with this that I haven't shown you. For instance, we have things like switch case for making view routers if you want to make complex applications with multiple views and all that, right? And this menu bar that I'm running up here is actually running Anathema. So if we look at this thing here, we can change this, right? Thank you for watching. Right, there you go. Right, this It's very exciting. I built I built my status bar in like less than 3 hours. I did this live on stream as well. So very simple, very basic, and it's a bit of a hack. But never mind that. If you have any questions, feel free to reach out or join me on one of my live streams on Twitch. Again, the URL is in the description. I develop Anathema live on stream, and if you have any questions or you want help with something, feel free to ask. I try to be as helpful as I can, and with the limited amount of time I have. But anyway, thank you for watching. I hope that you might find some value in this project. All right, cheers.